So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 203 and in this video we continue with our exercise, and in my last video I told you that you should challenge yourself and translate this code here in C++. It's almost done, but you have still to work a little bit to complete it. And if you tried it, very good. If not, no worry. I will show you here my solution, and I think it's very good that I explained this code also step by step, because this code here is an absolute pointer training because they create a lot of pointers here. And yes, you are learning to track pointers. And I hope you can. And I hope my drawing is not too bad because we are creating many pointers here. All right, let's get started. So first of all, I have created this code here already, my version, and there are different kind of versions. So you must be not one by one this code here, but yeah, as good as you can, because I realize we don't need here really a return node. But I don't know why they really need it, but I made a one without return node. Okay, I used also a return here, but my calls here down, where are they? Here, they don't need a return to create this list, right? So we could make also a void function here, but like I said, it must be not one by one, exactly like this one here, but similar to this one. I will explain it now. All right, let's get started. First of all, we create a function with a return value, and I created this one here too. And you can see I created a pointer return value. I don't know, I don't need it anyway. So I could make here a void as well without a pointer. And because I don't need it in my version here, let's make it a void. Or let's keep it, because it will also not hurt to have a return value, but it's never used. Let's say it so. Okay, let's go on. And before we go on, we have to talk about the parameters. The parameters here, you can see, is just the value which we want later put in. This one here, this 12, and this head node, it's new. What is this head node here? This head node here is actually the start node. So, and this head node is not created in this body of this function, which means we have to create this head node outside. All right, and I created this head node here at this point, and you can see this head node is just a pointer which I called score list, because this is a list for scores which I want made, and this is just a normal pointer and null.ptr. And I will again draw again, because like I said, we are creating here a lot of pointers and it's hard to follow. So let's create first this head pointer. This head pointer, let me draw this, and here I create a head pointer. I call this here my head pointer. In this case it's called score, but whatever. And at start it's null. And I write here just null. In real it's null.ptr. We use all time null.ptr, but just to indicate it's pointing nowhere. All right, this is our first pointer which we created, and we go back to our function, and you can see this head pointer here I call. So this is a function call here, add to list. Here is this head pointer which I created here, and I call it with a number. So you can see I set here the head pointer, and I assigned it to value 22 here. To 22 here. All right, let's go on in the function body of this here, and you can see the function body here is creating a lot of pointers too. But when we watch here the original code, you can see this is not a pointer what they show, but this I don't know anyway, is this a real programming language or is this just a pseudocode? I'm not really sure, but perhaps it is a programming language. They are using Lisp or anything else, I don't know. It's not so important. Important is that this first line here, you can see there they say the node temp and p. There are variables, but you can here already see in this line, this temp here, use the access access specifier of a pointer, which we learned, which means this temp here on top is a pointer, which means this p here is also a pointer. Why? No, that's not really true actually, but this one can be also a pointer. We can assume, all right, these two variables are declared as pointers. And in my case, you can see I declared them as well, but I used here separate lines for readability. And the problem is, we learned this one, you can declare in one line. For example, let's repeat this one as well. When you declare something in one line, and then you can, let me declare here something else, then you have to be careful that you don't make this mistake and write here, for example, test and think like so. Peter, oh, what's that? What do we have here? Yeah, that's okay. So the problem here is, you can see this test here would be not a pointer. So I have to use here a pointer as well. So you have to make this one here. And this is sometimes the mistake when you are declaring it in one line, that there is sometimes this mistake. But when you make a second line, like I did, for example, then it's easier to read. You see, okay, this temp is declared as a pointer. This one is a pointer. It's much easier to read. Sometimes this can really irritate, but that's not a big deal, I think, in general. But at the starter, I think this one is better. So, and you can see we creating two pointers here. So let's create these two pointers in our drawing, and let's call the one pointer is our temp pointer. I take here orange and make a little pointer here, and again null pointer. Let's write here also null, and here let's write here temp. This temp. All right, and we create here this iterate pointer. Let's call it just it, iter or something like that, with another color so that we can see that they are all different colors here. Let's call this iterate pointer. You can see we are creating a lot of pointers here. Iterate or something like that. Iterate. Okay, this one is an iterate pointer. That looks very bad. Let's write here just it. We know this is our iter or ite, something like that. Not too long. Iterate pointer, and it's also null pointer. Okay, let's write here also null. All right, so we have already 3 pointers so far, which we have to track anyhow and see what they do. So the next line here is calling a function, and this function we have to create. And you can see here in this, let's see what they have here. Yes, they make the same. I just copied this one here, and we have to create in this function a new node, assign it values, default values, 0 and pointing to null. And actually this node here we already created. I use just the node class here. And yes, default value is 0, and the pointer is all times to null ptr. So we can use our node class, which we already created. That's good, but we have created now this function who creates this new node, right? And I created here, and you can see the function which I created first is a function with a return value. And the reason for that is, you can see the function which is called here needs a return value, because we have here an assignment operator. So when you see something, a function is called and is used with an assignment operator, then we need a return value. So for example, in contrast, I set this add to list, my function to create this list here. I call it here, but I never use it. So the return value here, at least not here at this point, I never use it, right? So here I really don't need a return value, but here in this case I need a return value, because I want assign to this created node. So you can see we should create here a new node, assign it as a default node, and then assign this default node here to this temp, right? So this one here we need. to make it with a return value. Okay, I have this return value. I called it create node. All right, then what I did is, you can see I created first again a new pointer again. All right, so we have again a pointer. You can see we have here many pointers. Let's call this one here temp node. Okay, very similar name. All right, let's call this here temp node, temp tn, temp node, tn for this one. And this one is not null. Interesting is this temp node, it's at start, we can see not null like the other one. The other one was all null pointers, and this one is not null pointer. We see we are using again the new keyword new, and we create a new node, which means we are creating this one here. So what we can do here is, actually we are not creating this one here. We are creating first here a node, just so, a just new node, which we have to manage, right? And this one is using the default node class, which means it's using the default values 0 and null pointer here. All right, so with other words, we are creating here a 0 and here a pointer, which is pointing to null. All right, this is the thing what we are creating at this point here. Oh, oops, sorry, not here. Our node class here, this one here, right? This one. So you can see how many pointers we already have to track and see what they do. And let's see, and actually we have here one more pointer. Actually we have, this one is a special pointer. This is a class pointer. Let's make this one red. This one is also a pointer. We have, oops, let me make this one a little bit more clear. But this one, this class pointer is also a pointer. That's very important to consider, very important pointer even. Null. All right, so we have here already 5 pointers for here, and the class pointer also 5 pointers. Interesting. Okay. And now you can see this node was creating this one. And here again, like in our last video, we are using the keyword new, and we learned when we use the keyword new, we have to be careful. Why? Because this one is responsible programmer. You are manager, also you have to manage the storage here, right? We are allocating here storage on the heap, not on the stack. That's very important, which means we are responsible to release this memory later as well. All right, let's write here we manage. We manage. And all right, we manage this one. Is our responsibility to manage this one. All right, so far it's okay. That was this line. So the next line says here return temp node, which means this one here goes back to this place here, because this return node says, okay, you should return this created pointer here, and this pointer here can be assigned now. Here it comes here and can be assigned now to temp. But before that we do this assignment, we have here a problem. What happens? We know that here is a scope, right? And here we create this pointer, right? And here this one goes out of scope, and this temp pointer is destroyed. But careful, it is destroyed after the return node, which means this temp node is still here available to assign. Right? So can you see that? This is the function, so we can still assign it. Normally, if the scope goes out, this temp pointer gets here destroyed, and we could not assign anything. But because we have it here as a return node, the return node can be assigned at the caller's place, because it's still here available on this point here, which means this temp node which was created and which is returned here to the caller, because the return means I return it to the caller and I called it here, it's here available, and here at this point I assigned this temp node at this point to temp. So let's do this one. So let's see what happens there. So my temp node, which is this one, which I created, will be assigned to temp. So what means this? That means this temp here, this one here, is now pointing exactly to the same place where the temp node is, right? So it is here a shifting from null, because at start this temp here was created with a null pointer, that was this, and now we are assigning it the same place where this temp node is pointing. That means that here. But this assignment is through a function, right? Till now we learned all time direct assignment, and now we are using a function assignment as a return value. That's also interesting for starters. All right, so good. I hope you can see that. And till now, okay, but after this assignment, this temp node is destroyed, which means you can see the created storage here. One arrow is gone, but because we assigned it before the destroyment, before the here, this temp node get destroyed. Here it get destroyed, but here we assigned it first. And because of that, we have still access to this place. And it is very important that when we created a allocated memory, so we want to memory and allocate memory anyhow and manage it, that we have still access to it. And this one, at this point, this temp here is pointing now here, and we have access. That's very important, very important. But another question, where is our delayed node again? That was the discussion from the last video. All time when we create a new when we use the new keyword, you should at the same time use the delete, and then what we are deleting, this pointer here. And careful, when I say here delete, it means not you are destroying this pointer, you are releasing the allocated memory. Delete means not destroy. Very important. Yeah, that you get not confused with this one. This delete has a release memory meaning in C++. And when you are going out of scope here, then this pointer get destroyed. All right, but here is no delete, but we should use this. And we have discussed also in our last video that this delete can be not used when we have all time access it, but there is one time we have to release normally this storage here, because this one we have allocated and a compiler will not free this. And let's see when this one is the time. So here we have still access. So at this point, you can see that was this temp which we added with this function. We used now this pointer which we created, which was pointing nowhere, here to temp. Now we have still access. This one gets destroyed. So no worry, as long as this temp pointer is not destroyed. But when we watch this temp is also created here in this function scope, right? This one is the scope of temp, which means when we are going out of this scope here, this temp here will be destroyed. And in this code, there is no delayed keyword. So we could delete here. With other words, I could here delete this. Also, when I say delete, I mean then you can release this storage here as well in this scope now. But they are not doing this, at least not their code here, right? Again, which means we have to track and see what is the reason why they are not releasing it later after use or something like that. In this case, it's absolutely clear why they are not releasing this storage, because we are using it for a linked list, but we have still see when the time comes to release it, right? So let's continue this one a little bit. And you can see this temp here, this temp pointer, this is this orange one, is used now to fill this empty default node with data, which means it will fill now this 12 here in, and it will check this assignment operator. So because this one is just used to access, and how we can see this, the next line is telling us that the temp says, okay, I access first. We are using this arrow sign, and arrow sign means in C++, I use the access operator for this node. So temp here, this temp, it's here, gets into this node. It accessed now the first value, which is our number, the number which we want to assign. And then it says, okay, I take this number from top and I assign it to this place here. And which means it is assigning the value 12 here. That here becomes 12, okay. And then that was the first step. The next step is, then we have here a if-else check. The if-else check is already documented here. You can see it. And the first if is just checking if the list is empty, which means if there is nothing else. And the second else will only activate it if it was not empty, which means we have to call this function here 2 times to get first to this one. It's the first time. And when we call it a second time, then this one will be activated. All right, we will see this in a moment, what this means. Okay, let's do this. So first of all, this compiler will still go from top to down. So it checks as if head equal to null pointer. And let's see, what is our head? Yes, it is now to null ptr. Right now we have this head. This is the screen one, never assigned to anything, which means this block becomes true. This is the first time, and this block will be not executed. We know this, right? This is a normal if-else statement. So, and this block is a null pointer. Yes, this becomes true. We can see it. The head which we created is pointing still to nothing. And if this is the case, we assign the head to the temp. And you can see head to temp assignment means what? We watch first where temp is. Temp is here on this created, new created memory, which is actually this one here. And let's say temp is now here, but it's the same thing like here. It's creating this one, just filling up with values. So the temp, the head is now assigned to temp, which means the temp here, this one here, walks from here to here. And at this point, that's the thing what temp is doing. It's now pointing to this new created memory which we manage, right? So far, I think it's okay. And the else statement will be not activated. We know this because if this is already activated, which means this one is true, then this one means it's not true. All right, which means we can skip this one now here. And this one, like I said, is return head is, yeah, it's never used here, at least on my code. I made it just because we created here one with return value. Of course, we don't need it. We could make here just a void. It's the same effect like before. All right, let's see. This one is finished, but anyhow not really finished, right? So we have created only this first block here with this one here. That was the first step, and created this one here. And let's make here our first step. Let's make here our first step is our first block, because, and sorry, we are not finished. Of course, I forgot something very, very important. We created so many pointers. So let's see what happens with all these pointers, right? So let me go here back again. So with the first pointer, that was this temp node pointer, the temp node here, tn, get destroyed. Good. Let's go to the temp pointer. Let's make with this one. What happens to the temp pointer? The temp pointer we saw gets assigned to this place, access this value here, change the value, but at the end of this function, this temp pointer, which was created here, gets destroyed, not delayed, destroyed, because leaving off the function's body, the compiler is destroying this pointer. All right, this one gets destroyed after finishing this function here. The next thing, the iterator pointer which we created, I never used at least in this block here, this blue one gets destroyed. This one gets later destroyed at this point here, right? So then let's see what is left. So all is no. The only one which is not destroyed is our head. So the question is, wait a minute, why is head not destroyed? And the reason is very simple. All other pointers were created in this function body or in this function body, but the head was created here in the main function body and in the so with other words, this head here, this green one, will be destroyed when main function body is finished, and main will be finished when the program actually which we are making is stopped, is terminated, which means at the end of the program, more or less. Till then, this head here, this pointer head, is not destroyed. With other words, we have still access to this one memory which we have to manage, and that is one condition when you create a memory which we have to manage, that you have all time one way to access it. And you can see we have still this one way who can access this memory, and that's why we have not used delayed, because when we use now delayed anywhere, we would delete this list, and this is not our goal. We will use only delayed when we never use this list again, but we won't use this list, and that's why we don't use here this word delayed till now. That's also very important to keep in mind. Yeah, let's continue. So this was step 1. Let's write here 1. It's important to see what's happening in step 2, because they change a little bit, not much, but a little bit. So step 2 means I call this here with the, again, the same function here. Again, we do the same thing again, what we did a little bit faster, and we call this one again. So when I call this function, you can see I call it this time again with the head, which was not destroyed, here as my input, and 99 this time as the value. All right, and then I go up to my function again, like all time. We have to create, here's the head. The head I don't need to create because this one was created. That's good. Then the number is 99. Okay, but now you can see I create all the other pointers again, which means my step 2 here, I create the null pointer again. Null, I create this again, because that was destroyed before, right? It went from here to here, but here it gets destroyed. Then I create my iterator pointer. It was never used in my last program, right? This was not even used. Iter. Let's call this iter again, and again null. So, and then I create here again this create node. So with other word, I make my temp node again, like before, this tn. Let's make this one. And tn here is creating again a new box, which means which we have to manage again, a default one, which is, this one is red, this one is to null. So you can see this one. All right, so I think these steps are now clear, right? Because we have just discussed them, and you can see the temp here. Wait, this one, it's creating this one. That was this creation, but this creation assigns also at the same time to temp, which means again, like before, temp, which was here new created, is moving again here. So it's pointing again here. And after this creation, our tn, which was created, is destroyed after the function call. That was here, this one. Here we created, here it's assigning it to our temp, and at the end here, this temp node is destroyed again. So it's destroyed, it's just creating this one, but we have still access again with this temp here. All right, so far so cool. I hope now it's very easy to follow because we have already discussed all the parts. And now let's see what happens here with this if block, because this if block is still cold, right? So let's see. The if checks the head, and the head checks if this head is to null PTR. Okay, this is the green one, but the green one, you can see it was not created because it's still there, because that was never destroyed. It was here created in my main, and my main was never closed. This is still here, which means this if goes checks here, the head was started here but moved here, and the head is not null PTR. So with other words, here it was null, but now it's pointing to the first node. It is not null PTR, which means the if first block will be skipped. And now we are using the if else block, this else part. And now we have to discuss this else part here. And let's do this one here. So what happens in the else part? Now this iterate pointer, which was never used, that was this blue one, it's assigned to head. So where is our head? Our head is actually pointing this one here, which is not this one here. This is the first one which we created, and the first one is actually this one here. So let's make it this way, that it's a little bit easier to follow. This head here created the first node, and the first node created this block here, and the head is pointing here, right? So that's here a little bit one, and this is the first node. And the second node, which is this one here, it's creating now this block here. So let's write here first. And this one will create our second, right? So one block for this one. The second block will create this one. But the head is still pointing here. So let's go back here again to this line here. So the iterator pointer, which we never use, this blue one, is doing what? It is pointing now to head. Head pointing means now it is coming to the same place where head is. Okay, the iter is here now. You can see it is going from here. Actually, that was wrong. Sorry. No, that was not wrong. That was right. Very important. The head is not on the second node here. You can see we are normally here, but our head is still on the first node. That's very important. And this iterator pointer here is going to the head, like here, to the head pointer, which is still here. So with other words, we are pointing indeed here, not here. That's very important. And then this one is now using the iterator pointer. Okay, let's see what happens then. Then we make a while loop. And this while loop, we already discussed about this one while loop, which I showed you in one of my other videos. It's the same thing here, actually. So what they do is the while loop checks first a condition. And the condition is, it says, okay, where's the iterator pointer pointing? The iterator pointer is pointing to the first one. Here, it's the blue one. And then it says the iterator pointer should get access now to this node. So this iterator pointer get access, and it should access the pointer to node, which is this red one. And the red one we have made here. So this blue one here is accessing this red pointer here. And at start, this red pointer here is pointing to null. We have never set it. So we have here another pointer, this red pointer. All right. And if says here, okay, if this red pointer here is not a null PTR, which means if this is a null PTR and it started would be a null PTR, then we should go here in this loop body, but we have a null here, which means we are never go in this body, right? This one is not null PTR, and we have here a null. This red one has never been assigned. So which means we are not entering this body. We are going to the second here, to the next statement, and it says here this iterator pointer, again, this blue one, should access this box here. Okay, it is accessing this box here, the first one here. And it says, now assign the red pointer, so this blue pointer is accessing this red pointer, and it says your red pointer should be assigned to the temp. All right, now we have to see how we make this. That's a little bit hard to, I think it's not hard, but anyhow, picture is really hard. So this red pointer should be temp. Where is our temp? Temp is on our second block here. It's pointing here. So the temp is right now pointing here. That is this temp here, because you can see we are here on the second block. And this one here, access now this red pointer, this one here, and says this red pointer should now point to the to temp. And temp is pointing to the same place, so the red and temp now pointing here to the same place. That's very important that you understand this one. And this is important, this assignment is important because you will see in a moment the function here ends. Again, this return, which we are not using, but the function body ends here. And the question is, okay, what's the problem? The problem is, you can see the head is, let's see what pointers are destroyed again. Let's make this again. Which pointers are destroyed? Because important is that we have all time access to the created memory. And you can see we created this one here in step 1. This one here in step 2. This one is our, oops. This one is our step 2. Oh my god, my drawing. When I draw a little bit better, then it would be cool. All right. Okay, then I hope that's okay. So this one we created in 2, and let's see again which pointers are left. All right, let's follow the steps again, so we can see our temp pointer get destroyed again, but not here, here, like before, destroyed here. Our iterator pointer, this is our blue one. This one is created, but it is assigned here backwards. You can see it's created in block 2 normally at this place, but it's assigned backwards to head, but it's destroyed after this one, right? So again, at the end, this one is also destroyed. Yes, let's destroy it here as well. So this one gets destroyed as well, but we know it's assigned backwards here. Cool. All right, let's go on. Which we have? Temp is destroyed, iterator is destroyed, and you can see all the nodes here which we have are destroyed. Ah, wait, we have now how many pointers left? Actually, you can see it. This blue one is destroyed, right? The only one which, not the only one, the only 2, we have now 2 left pointers, is the green one, which is our head. That was that. That is the access point, which I said will be destroyed when the program ends, but we have one more. Now, the red one is not destroyed. Why is this not destroyed? Because the red one points now from the green one, from this box to this box. And this is the only access point between these 2 created the new memories. Can you see it? Because the point is here, we have only one access to the first one, but the first one has a pointer to the second one. And this is building our linked list here. So we have still 1, but now 2 pointers. I hope you can see that. And when we go one more step and create a third step, let's make here a third step. And you can see, again, I call here the class, And then it creates again all the pointers again. Let's make this a little bit fast now. Here it creates again null, temp, and it creates here this iterator pointer again. I think you understand this now. Iterator pointer null, and here it creates again, after this create node, it's creating again this node. This new node, this is again a new node which needs to manage. This is this node here, which will be, but first it creates the default one and then it fills it with the values. That's why it starts all time with 0 here and then with this default null. That's very important. Null, here it's null. And then again this T, it was this temp node. All right. And that's more or less it. And now you can see what happens. It happens now all time the same thing like before, but let's see if this is true. And because here is one other step, I think. Because we skipped here this while loop, this time we will probably not skip it. That's why I made it. So let's go here fast again. Okay, we start again. Okay, we created this line. That was our temp. We created this one. That was our iter null. We created this temp node. Yes, we created a new node. This temp node was created here. This temp node assigns this temp. So we have to assign this, which means this temp is again coming here. That's very important. That is this assignment. And now this is okay. And the next step, as you can see here, temp data. Okay, we fill this one with data, which means we are going here and right here. This is now this creating this one here. This 37, this we're filling it up. And then it checks again. If head null pointer, we know head was never created. Head stays till now at the same place and head is still at 1. You can see head was never moved, was one time assigned to the first node and never moved again. Okay, this case will be never activated again because this one will be only, yes, if it's empty, because only if it's empty will be null pointer. Okay, this one we can skip. Then the else block will be activated. Again, we create, we assign iterator pointer, which is here, this one here, is assigned to head. Important, this one is important. So we are here in this block here, actually, and let's delete this one here. This temp was anyway destroyed. So we are here in this block, right? This one, free is this block here, creating with this one here. And important is now this iterator pointer here. Look what happens here. The iterator pointer, which is again created from start, null, is assigned to head. And where is head? Head is again at start. So this iterator pointer will be assigned all time to head. And head is all time at start. And then this iterator pointer checks. Check what? It check get access. So the iterator pointer get access to the pointer node, which is this red one here. And then it says, okay, red one here. This one means you are accessing now the red one. With other words, you are using the red one. This one, access this one. Now you are the red one. And now, red one, are you the null pointer? And at this point, the red one says, yes. Why it says yes at this point? Because it's not the null pointer. I'm not the null pointer. I have here a value because after the first step, that is after this one, the second step assigned the first one to the second one, right? So the second one assigned this one here. So we are going indeed now in this body here, which we skipped before. And it says, okay, iterator pointer, if it's this the case, now iterator pointer, go first in pointer to next, which means the iterator pointer self goes here, then it takes the red one, where the red one points, which means the iterator pointer iterates, iterator pointer, sorry, this line here takes the red one and it assigns where this red pointer is to the iterator pointer. So the iterator pointer is here, and now it says you should iterator pointer point there where this red pointer is. That one here is the red pointer now, right? Can you follow this? And then this one is switch. Why I have not here this? No. This one here now is switching the place because this iterator pointer is following this red pointer here. This is the early connection, by the way, between these two here. All right, now again, after this one here, it goes back to start and checks, hey, iterator pointer, access this now, this block here, and check if this pointer to node, which is this one here, this red one here, is a null pointer. And at this point, it is a null pointer because that was the second step, and we have not assigned this null at the second step to anything, right? So this pointer is indeed a null pointer, which means the loop will be skipped. It will go no more on. And the iterate pointer says again, okay, iterate pointer, this is the blue one, pointer to node, which means iterate pointer access the red one, this one here, which is pointing to null, and says you should point to temp. Where is our temp pointing? And you can see our temp is the third block, and temp is pointing here again at this point, which means this iterator pointer access this one and set this red here. And this red one is not destroyed. But when we end here again, the scope is ending here again, and you can see what happens again like all time. The temp here get destroyed like all time. This one was only used to assign this value here, but after this one get destroyed. And let's make it here in this block 3. So this one get destroyed here. An was anyway destroyed before already in the function body on top, and the iterator pointer get destroyed. And you can see the only pointers which this blue one, the iterator, is also destroyed. You can see that was only this iterator pointer was only used to go to the next place and make a connection. So this iterator pointer iterates, finds the last node and builds a connection. And again, only the head is left like before, and the red ones. Now we have here actually not one red pointer here, this one. We have two, because we have this one is connecting this one is connecting this one, and this red pointers here are actually creating our linked list. This is the only way to access this memory block, this one, and so on. The first one is accessing the first one, and the second one is just accessible through this red pointer here. So I hope, I hope you understand this anyhow, and you see how many pointers we made here. It is definitely a pointer, a pointer training and a little bit track training. There is one more thing, of course, which I have to say. Like I said before, we create here this new, right, and delayed. And again, that was similar to the last video where I explained to you why we have not here a delayed keyword. And the reason for that is, if you delayed here anything, for example, if you would delete this pointer, if you delete here the create this new created block here, you are releasing this memory here and all the input is away. But we make here a linked list, which means we need this info till we don't need it. And actually at this point, it means we need it till the program terminates. And when the program terminates, which means our pointer here, this head pointer, will be destroyed when the program terminates. And when the head pointer gets destroyed, we have no more access to this block, and actually to no block at all, which we created in our linked list, which could lead to memory leak. But the point is here very important, because the whole program terminates, because int main we are finishing, and int main finish means the whole program is finishing, and all the resources of this program, which was an application, are given back to the operating system. For example, in my case, I use Windows, then all the resources for this program will be given back to the operating system, and the operating system will free this memory for you. But on the other side, if you would continue, for example, anyhow to use this anywhere else, I don't know, and this one was also in a function where this this head node would be destroyed, then that could lead to a big problem. And then you would need to use delayed. For example, what I mean is, let's say you can see I created here this list, right? And let's say this list was created not here, but let's say in another function. We can make this. Let me see if I can make this, show you this. I can go here to select all this kind of stuff, right click. We can go here to not breakpoint, where is the snippet, and surround with. And we can surround this, or we can extract this. Let's see if we can make a function. Here is quick actions I showed you, extract to function. Okay, it's not working. But think about it. If this one was created in a function, right? And then, or let's say here in a scope, perhaps we can make a scope here. Then we have a problem. Then we should have a problem. But it's not so very important now to demonstrate this. But you can see here, I would create a memory leak. And why so? It's very easy. Here, I created a scope. A scope would destroy this pointer. This is this head here. The compiler would destroy after the scope this pointer here. That means this one is destroyed. Here, all the memory here is still connected and not released, which means here you should release now anyhow all the allocated memory here when you create something like that. That's very important to keep in mind. I do this not now because that takes now too much time. I hope you understand now all thing anyhow. And now there is also a print function. We have not talked about the print function, right? In the last video also not, and in this video also not. Oh, okay. We will talk about the print function in the next video, I think, because this video is already too long. But I show you that this is working. And the question is now, why the hell we make all this way? Why we did all this one? The last video which I showed you was very short in compared to this one, and the reason is here the entry is from start is ordered. What I mean is, if you get here the first number 12, for example, and you print this out, it is probably also not 12. Oh, the reason for that is I have to watch this. I think I'm printing here something wrong out. Let me see this one. Comment. Print list, score list. And here I'm printing nothing out. Why I print here nothing out? Okay, let's keep this one. I will make this in the next time. because I will not, we will talk anyway about printing out this one. It worked before. I probably changed some names here, and that's why not. It's not working anymore. And anyway, but I hope you understand this one here. And yeah, you can see it's a very good pointer training, and you can see pointers to track pointers. Yes, it's not easy at start. You have to train this. Yeah, that's normal, but don't worry. In future, we want not use many pointers. Many programmers say you should anyway avoid as much as possible pointers, because yeah, you can see the reason why. It's a little bit complicated to track, and that means, with other words, you can make easy errors. So that's the reason why many try to avoid pointers in general. And with that said, I want to stop here. And if you have any suggestions, any comments, like all time, write it in the comment section. And see you in the next video, where we talk about the print functions, because I showed you net how to print out this values here. But we will also go on here and talk probably about some sort functions, because about a little bit sort theory here. You can read this already, because sort is a big topic in programming. There are different kind of sort algorithms, and we will talk about some and try to implement some here. And later, because I want probably use a sort in my linked list. So we will have to see which one is good or not. All right, with that said, we'll see you in the next video. Bye, good luck, and like all time, never give up and have fun.